Hello, we are Group 6, and the following is our training video for Lab C, gas stripping in a packed column.
In this video, we will be discussing elements related to the operation and safety of stripping in a packed column. In particular, we will be using air to strip ammonia from an ammonia-water mixture. Stripping is a process where components are removed from a liquid stream by a vapor stream. Stripping is usually carried out in a packed column as the packing creates a larger surface area per unit volume ratio. This is important due to the fact that the surface area available plays a large role in dictating the amount of mass transfer that will be possible. Some important aspects related to the packed column are the flooding velocity, column diameter, and packing height. As a rule of thumb, the gas velocity is typically set to 80% of the flooding velocity. This gas velocity then dictates the size of the column diameter. The packing height can be determined through correlations for the height and number of transfer units needed for a given separation. The main objective of this lab will be to determine the flooding velocity, theoretical packing height, and outlet stream compositions.
So why should we care about this? Stripping is important because it allows for a great degree of separation and purification. As a matter of fact, oftentimes it is more efficient than simply filtering out larger particles as is with filtration processes. In addition, it can also separate dissolved compounds rather than only suspended compounds as other separation techniques do. An important use of stripping in industry is its employment to remove organic compounds from wastewater within a process, and a large variety of industrial processes have some form of wastewater. In terms of equipment used, to conduct this experiment, a liquid holding tank for the ammonia-rich solution is required. This tank is to be connected to a liquid pump, which will transport the liquid flow into the column, passing through a liquid flow meter. In addition, an air blower also forms part of the setup to transport the vapor into the column, passing through a gas flow meter. Lastly, an ammonia selective probe is to be used to analyze sample concentrations.
The procedure for this lab will be broken up into 3 parts, the first of which will be allowing the column to reach steady state. Before you'll begin, you'll want to note the placement of each of the valves, pumps, and equipment to ensure that you understand the flow of the vapor and liquid throughout the process. After this, you'll ensure that the gas outlet tubing is placed in the hood. This will ensure that no ammonia will be released into the room. Additionally, you'll check that the gas valves and meters are open to ensure that the equipment won't be damaged. Once you've ensured the safety is in place, you can go ahead and turn on the blower and pump. Once you do this, you'll adjust the liquid flow rate to 0.05 gallons per minute and the vapor flow to roughly 2 cubic feet per minute. Once you do this, you'll also want to check that there's no flooding in the column. After the flow rates have been reached, you will wait 20 minutes for the column to reach steady state. This will allow us to take samples. Once this has reached steady state, you will collect 4 50 milliliter samples. 2 will come from the bottom of the column, while 2 will come from the feed tank. Before you take these, you will need to drain the taps in order to clear the buildup from past experiments. This will ensure accuracy in our results. After this, you will measure the ammonia concentration from the sensor in the fume hood. The next step will be analyzing the concentration of the samples. This will be done using an ammonia ion selective probe, which is very sensitive to ammonia. First, you will add a caustic solution to drive the equilibrium reaction to the left, using 1 milliliter of 1 molar NaOH solution. It's important to exercise caution using the sensor to ensure that you don't damage the sides or the membrane located on the bottom. After this, you will check for flooding conditions. This will be done by setting the liquid flow rate to 0.1 gallons per minute initially, and then gradually increasing the airflow rate until flooding is reached. You can ensure flooding has been reached by seeing rising liquid and air bubbles at the bottom of the column. You will also notice a different noise pattern. Finally, once true flooding has been reached, you will note the conditions and then turn off the compressor and blower. The main thing to keep in mind during this experiment is safety, particularly the safety concerns involved with the chemicals. The main chemical being used is ammonia, which can pose a hazard in a number of different ways. The primary concern for this lab will be inhalation. This is such a big issue due to the fact that it can easily be inhaled through 2 main components of the procedure, both from the tube in the fume hood or during the purges required while waiting for the column to reach steady state. Aside from being inhaled, ammonia can also easily damage one's skin or eyes, so it's important to ensure that you keep your PPE on throughout the duration of the experiment. In terms of other chemicals, the caustic solution used to analyze the samples can also be a significant hazard in the same manner, and it requires extreme caution while handling it.
In terms of other safety precautions, further considerations include wearing personal protective equipment while performing this lab and handling all glassware and equipment such as calibration sensor with care. Other hazards include incurring in large liquid and vapor flow rates, which could damage the column. It is also really important to avoid running the compressor without first opening the gas flow valve to avoid damaging the pump and possibly generating an accident. As for waste management and disposal, it is important to highlight that the purged liquid can be reintroduced into the holding tank because no chemicals are being mixed. This is, however, a two-person task. One must open and close the valve while the other holds the recipient with both hands for safety. In addition, since this lab deals with ammonia-rich waste solution samples, it is paramount to dispose of these in the appropriate waste bin container under the fume hood.